might have gone through the theory in your synchronous machines that the synchronous machine is having armature winding on the stator and the field winding on the rotor, and the field winding is supplied by the DC source, right? And there is an effect of the change in the excitation on the armature current, power factor, etc., right? So we want to verify the same thing. But before going to perform that, let us briefly recall why it is happening. Why there is a change in the power factor or the input current because of this change in the excitation is happening, right? So the basic phenomena or the fundamental behind that, as you all had studied the vector diagram of the induction motor, in that you have a relation between E and V, right? So if your machine is under excited, right, what you are having, your induced EMF E is less than that of supply voltage V with some angle, and there is some angle phi between that, right? So due to that, the overall power factor of the machine is lagging, and machine will draw current from the source, right? Now as you go on increasing the excitation, DC excitation, gradually the current taken from the source is going to decrease as the EMF, E vector is going to increase, right? So both V and E are now becoming almost equal, and at some point of time V and E are same. So that will make a unity power factor condition technically, and your current at that time is minimum, right? So earlier the current was high, right? Earlier the current was high, and it is gradually reducing as you are increasing the excitation. At some point of excitation you are having the minimum current. Likewise, power factor was poor or lagging in the initial phase, and now power factor is improving, and it is trying to reach the maximum value. Current is minimum, power factor is maximum. Again, if you go on increasing the excitation, then it is going in the overexcitation mode, where the E becomes more than V, right? So power factor becomes leading, and again it is becoming poor, right? The power factor becoming poor, right? It is decreasing, and hence the current starts increasing, right? So these two curves, V curves and inverse V curve, are known as the V curves of the synchronous motor. V curve is for the current, and inverse V curve is for the power factor, right? So we try to see that thing practically up to possible extent, right? For that setup, this is our synchronous motor, right? And as you all know, that synchronous motor cannot be started automatically. You need to make certain arrangement to start it, and one of the method is that you start it as an induction motor and then convert it into the synchronous motor. So our motor is having the same mechanism, right? In that, this is the changeover switch. This is the changeover switch. If the switch position is like this, as it is shown like this, it is in the induction motor mode, right? So now if I am giving the AC supply to this motor, it will start like a normal induction motor, right? And when the motor comes to the normal speed, then I will change over this handle to this side. That will initiate my DC excitation to the motor, right? So this is the synchronous motor which is start in the mode of induction motor, right? Now how to control, right? For controlling the DC supply on the synchronous motor field side, we have provided, see, this is a positive field supply. This is the field supply, so it is from positive to this emitter, so which is measuring the field current. From the field current to, we are having a rheostat to control the excitation, and from the second terminal of this rheostat, right? From the second terminal of this rheostat, you are going to the F, right? So and from double F it is negative, right? From the double F it is negative. So this is the connection for the field side. Now for the armature side, we have taken the AC supply, fixed AC supply, that has been converted to the variable AC, because we don't want to initiate a very heavy starting current, so we will start it by like a auto transformer starter, right? So we will gradually increase this voltage. The same supply is given to the motor. Now here comes, as we have already talked, that we want to have different measurements, like we want to measure the power, we want to measure the power factor, we want to measure the voltage, supply voltage, we want to measure the supply current. So you can see here there are 4 meters. This is a voltmeter, this is the power factor meter, and this one is the watt meter, and this is the ammeter, right? So instead of all this, and unfortunately the power factor meter is having certain issues, so to have our measurements, we have used this power analyzer, right? This power analyzer, which is having all the facilities. You can measure the voltage, you can measure the current, power factor, and the power, right? So now we are going to start our machine, and you people can observe the effect of excitation on the various parameters over this power analyzer. Proof that our induction motor is starting, our synchronous motor is starting as an induction motor. Let us try to see that what is the effect of this switch, handle switch, right? So what I am doing right now, I am turning on the DC supply, right? And my switch is in this position, so that it is not supplying a DC to my motor, right? So that we want to check, and then we can change over the switch position, and we will observe whether the current is flowing or not. Still we are not giving the main AC, so the motor will not rotate. But just try to see that what is the effect of this handle, right? So I have supplied the DC nearer to 110 volts, right? And you can see right now the circuit is already connected, right? Circuit is already connected, and you can see that current through this is still 0. Okay, right? And now you can see I am going to change over the switch, and hence you can see the current has been changed. So the point to show over here this thing is that this is not a just switch for some demonstration purpose. It is actually the switch which enables our motor to run as a start as an induction motor, and then we will convert it into the synchronous motor, right? So I am putting it back, right? So you see current is 0. Now let us start our machine. Make sure that the variac is at the 0 position, right? And then I am turning on the main supply. Now mind my friends, this meter is supplied by the auxiliary AC here. So somebody might have doubts, sir, there is nothing given, then how this is working? It is having its own auxiliary supply, which is for its own power. All the measurements will be taken from our whatever the current and voltage which is passing. Now I am gradually increasing the voltage, and we will try to see to maintain 230 volt here. And you can see that now motor has started rotating now. So voltage has been set up to 230 volt. You can see the power factor right now, right? It is very poor, right? And the current taken is also power W is also 0.15. Now I will change the first line of display to the current, because our voltage remains constant, but current is going to vary, so that I am changing it to the current. Now you can see there is a no load current of 2.5 ampere which is flowing right now, and now you can see the effect of the switch. You can see the instantaneous effect of the switch on these motor parameters. Now I am going to change the position of the switch and applying the DC. Right. So the current earlier was, no doubt it takes some time to settle down, but current was 2.5 ampere. Now you can see the current, right? So effect of this excitation on the current, right? Somebody might be thinking, sir, why this is the jump? Because right now we have adjusted our field winding in the middle position, our field setting almost, right? So now what we want to do, I am changing this current from minimum to maximum. Sorry, let us take it. This one is the minimum one, right? So this is my minimum current, and from that I can go to the maximum. So what I am saying, I am gradually changing my current from minimum to maximum. You people please observe that what is the effect on this power analyzer, right? So I am again changing that from, it is right now at the minimum current, minimum field current is flowing right now, right? And you see what is happening. Start. Okay, so observe the variation, change in the field current and change in the motor current, motor power factor and the power. You can see that the power factor is increasing, and now it is again decreasing, current is increasing, and now it is over excitation mode. Okay, this is all about weak cause of the synchronous motor.